Alright, in this video I'm going to show you how to solve a three unknown, three equation system by using elementary row operations and reduced row echelon form. Alright, first we want to put this system into an augmented matrix. To do that, we look at the coefficients and the answers to these equations, alright, and place each coefficient into a matrix, as you can see here. See, we looked at the coefficients of like the x1s, the x2s, and x3s, and then the answers, and placed them into a matrix where the 1 in x1 goes here, the 2 in x2 goes here in the second place of the first row, and the 2 in x3 goes in the third position in the first row, and the answers are always in the last column. Okay, placed accordingly. Now, what we want to do now is put this augmented matrix into reduced row echelon form. And you may wonder what reduced row echelon form is. Well, reduced row echelon form has four properties. Okay, the first property is if a row does not consist entirely of zeros, then the first non-zero number in the row is a 1, which we call leading 1. Okay. The second property is if there are any rows that consist entirely of zeros, then they are grouped together at the bottom of the matrix. Okay. Property 3 is if any two successive rows that do not consist entirely of zeros, then the leading one in the lower row occurs farther to the right than the leading one in the higher row. Okay. Property 4, each column that contains a leading one has zeros everywhere else in that column. And here are some examples of some reduced row echelon forms. As you can see, each of these matrices follow these properties. Okay, where, for example, in this case, the leading ones column has no other, are all 0 except for that 1. Okay, and also the higher row, leading one is to the left, and then the bottom row is the leading one to the right. Okay, yeah, and that's it for row reduced row echelon form. Now, in this case, okay. Yeah. Now, to get it into that form, we want to use the elementary row operations. And the elementary row operations there's three of them. Okay. Now, you can multiply a row through by a non-zero constant. You can also interchange two rows. Or you can add a constant times one row to another. So that's multiplying one row and adding what it would be to another row. Okay. Now, if we look at the augmented matrix again, right here, all right, we first want to solve this, we want the yeah, we want the bottom, or we first want to solve where the main diagonal are all ones. The main diagonal is the diagonal that cuts through where the leading one for the first one is 1, and the second leading one is for this 4 is a 1, and we also want to solve first where the below the main diagonal are all zeros. Okay, then we want to solve for where all the above diagonal are all zeros. Okay, so in this case, okay, if we look here, we can see that since we already have a leading one here, and we want these to be zeros first, okay, we have to multiply this top row by -1 and add it to this bottom row. Okay, which when we do that, we get this augmented matrix now. Okay, now because of this, both or below this main diagonal, it is all zeros. Okay, now, before we continue, we want all or the main diagonal to be all ones before we can make this top above the main diagonal to be all zeros. And I will continue this on the next video because of time constraints.